Some of the most dangerous storms a chaser can encounter aren't the pretty ones. High precipitation supercells often hide their most dangerous features behind curtains of rain and hail. Tornadoes can be completely wrapped in precipitation, giving chasers almost no visual warning. In this episode, we'll talk about why HP supercells are so dangerous and how to recognize them before they surprise you. I'm Gabriel Harber, host of the Storm Chaser Coaching Podcast, and I'm here today with lead coach Trey Greenwood. Trey, how you doing?
I'm doing well, thanks.
Before we get started, there are podcast notes linked in the description below if people want to follow along at home, if you want to have them for future use. Just go ahead and click the link, fill out the quick form, and we will email those over to you. Trey, question number 1. What defines a high precipitation supercell?
High precipitation supercells, or HP supercells, are going to be those ones that are, as the name suggests, very heavily loaded with precipitation. So whereas a low precipitation supercell, you might not see any visual evidence of actual falling precipitation. Your classic supercell, you have your nice rain-free base with the precipitation vented off away from it, and you can see all the storm features. Not the case with an HP supercell. An HP supercell will have lots of precipitation co-located with that updraft base, and so all of your storm features are usually going to be masked by strong, heavy precipitation, and that can make these very dangerous to chase.
Why are HP supercells especially dangerous for storm chasers?
As we said, your features of note that you'll see with the low precipitation or classic supercell are just not going to be visible with a high precipitation supercell. Any type of rain-free base or wall cloud where tornadoes can come from, obviously, those are going to be hidden by precipitation. You might just see a big wall of rain, and you're not going to be able to make out the features like you would with other types of supercells. So that makes you rely a lot more heavily on radar, and the only way you're going to see these features, any tornadic activity, is really going to be right up in the inflow notch of the storm, right up in that hook echo in the bear's cage, and that can be an extremely dangerous situation to be in, especially in a very heavily a high precipitation supercell like that, where even that close you may have difficulty ascertaining features. So it's just a very dangerous situation overall because you just cannot see the typical features that we identify with supercells.
Just for my own curiosity, what are some examples of high precipitation supercells in the past that have gotten storm chasers into trouble?
The main one there is El Reno in 2013. At times the tornado was visible, but most of the time the tornado was very much shrouded in rain, and all you could see was just a big blob of rain where the tornado was. Most of the time, the folks who saw those tornadoes were very close to them, wrapped up right up in the notch, right up in the bear's cage. And as we know, of course, that was a very tragic day because of the deaths of the amateur storm chaser as well as Tim Samaras and his crew. They were operating very close to that tornado, and in that case, you can get very deviant motion as well. And that was one of the things that happened that day and just caught them off guard. That was probably the biggest example and the most notable example of a high precipitation supercell that went awry for chasers.
Yeah, and following down that same road, I have an example as well that I can give personally, which really opened my eyes early on in my chasing career. And I actually am quite thankful that even though I didn't see the tornado, it definitely put my expectations in their proper place because I was at the Bassfield tornado, the EF4, one of the widest tornadoes of all time. I was on that storm. Had that been in, first of all, not Dixie, where I could have actually seen more than like a quarter of a mile out into the terrain, but also if that had been at least modest precipitation or low precipitation, I would have been able to see that storm. But it was crazy to me to know after the fact that there was a tornado over 2 miles wide doing EF4 damage, absolutely catastrophic. And it just looked like another thunderstorm to me. I literally couldn't pick out any identifying features. And I was like, wow, it would be really easy, especially since I was a brand new chaser at the time, for me to have been caught in that without even realizing that there was a tornado bearing down on me.
Exactly right. I was on that storm as well, and it was just, and that's how it is in the southeast a lot. You just have very high precipitation storms, and that the combination of that with the very difficult terrain and visibility, that's just what makes the southeast so dangerous. Of course, anywhere you get an HP supercell, it's going to be dangerous for that reason, because you could have a very strong tornado hidden back in the rain, and the only way you're going to see it is pretty much being right next to the velocity couplet, and that, of course, is just extremely dangerous.
Before we go on to the next question, I just want to remind everyone that we have an awesome Discord community. The link is in the description. Our members are always talking about storms. We have a forecasting and storm chasing forum specifically where we will discuss every single day that has storm chasing potential. And our coaches, of course, as well, will answer questions if you become a member of our Chaser Academy. More information about that in the community once you arrive. Trey, what radar signatures typically appear in HP storms?
We talk about for classic supercells, you'll have that nice, well-defined hook echo appendage on the southwestern flank of the storm. But that's not always going to be the case with a high precipitation supercell. Oftentimes you will have a nice hook echo, but it might be very thick or it might be very shrouded in rain. You'll have a lot of rainfall in the inflow notch, which with a classic supercell is nice and clean, very precipitation free in that inflow notch from the winds that are flowing into that storm. That's not the case with a high precipitation supercell. It might just look like a big old kidney bean shape where you have that hook echo hidden in there, but it's really masked by a lot of other precipitation around it. So you might just see a big old kidney bean shape instead of that nice classic hook echo. That's probably the main difference in reflectivity between a typical classic supercell and a high precipitation supercell. Other than that, you will probably see your features like a velocity couplet in radar if a tornado's in progress. That doesn't change. Really, it's in the reflectivity display and it being very much less defined, the features on radar for an HP supercell.
What are the main hazards you can expect with an HP supercell versus a classic supercell?
So you're going to have all your same hazards usually with an HP supercell as you would with a classic supercell: tornadoes, damaging winds, and large hail. But with a high precipitation supercell, because you have a lot of precipitation in the mesocyclone region of the storm, that sometimes is not as favorable for tornadic activity. Of course, there are plenty of exceptions where you can have very strong tornadoes with high precipitation supercells. Oftentimes, there's other factors at play on the storm scale or the meso scale, but you really need to keep an eye out for very large hail with these cases. A lot of times, high precipitation supercells will have a very dense precipitation core with very large hail inside it. Also, a flooding risk. That's something that is not talked about and thought about by storm chasers a lot. But if you're trying to chase a high precipitation supercell on dirt back roads that can easily turn to mud, and you're trying to get close to the circulation or close to the storm, you really need to be very careful with that because, again, very heavy precipitation can lead to a quick degradation of the quality of those roads and can lead to areas of flash flooding, especially with slower moving storms. So you can get all your hazards with high precipitation supercells, including strong tornadoes. They may tend to be a little bit more deviant as well. But most of all, a lot of times you really need to pay attention to large hail and flash flooding with those, as well as damaging winds. You can have very strong outflow because of all that cold precipitation falling out and cooling the downdraft. It allows it to accelerate down to the surface, and you can get some very strong outflow winds as well. So really all your hazards are applicable with HP supercells, but the ones that are not thought of as much might be large hail and flash flooding.
Remember to check out those links in the description below, and then watch another video.